So I want you to know, like in the past, we had chapters, we had a section where there was the lecture material, learning resources, and then there'll be a homework quiz with the solution guide or solution video. There's 5 or 6 questions. What I'm going to work to do is get those integrated into the class so that while we're doing the class, we're actually working through things. And then there was some homework, and again, it was just a big chunk of stuff that a lot of times you run into questions. You can only do so many questions from the lecture until we got all the way through a chapter. So what I've done now is for chapter 8, I've broken it down where each thing is, so we'll do one section at a time. So it's section 8.1, click on that, see what's in there. And what you'll see is each of the sections, there'll be the textbook, which I've broken down. So this will only be 8.1. The other one, there was a textbook with the whole chapter in it. This will just have the stuff here. So a good practice to get into would be to take a look before class as we're coming up. So Thursday, we'll be looking at sections 8.2 and 8.3. You might want to at least come in before you come to class. Of course, you maybe couldn't do it today, but take just kind of quick look over. If you want to read it, you can read it. That wouldn't hurt, but at least kind of see the types of things we're going to be doing. We're working on something called confidence levels today. So at least when you come in with a little bit of background. There's some homework in here, but again, we're not doing those. Those are kind of integrated into what we're doing. But notice this is just 3 quick pages, at least taking a gander at it. So that's why those are there. There'll be our class learning activity, which is what we'll work through. And then there's the homework, which I've reorganized. It's the same questions that was in there as one big block. But I found out with this one, the way they had it set up, the homework block for chapter 8 actually started with the stuff that's in the last part we're going to cover. So the order was all messed up. So when you come in here, there's going to be this actually only has 5 questions. There's only 5 questions out of today's lecture, which you can't get to yet because I've got to set it up as a teacher. I forgot that's the one part I was doing this morning. I had to set it up for all 4 classes. So I'll get this going, but you'll see that now once the lecture's done, you'll have 5 or 6 questions to do, get the homework done, and then we'll have those in each of them. The way this one ended up getting set up, there's like 5 questions for this one, 5 questions for 8.2, but then 8.3, we pick up about 16 questions. But the goal is to get you working through the homework as we do things. So it's not just push it off, and to hopefully get you interactive as we go through the class. So while we're not fully there with the interactive, if you do have your laptop, or if you don't, remember, everyone's got a computer hiding in front of their desk or a tablet. You'll be able to follow along with this one, and I have at least 1 or 2 times where there'll be the use of the NumWorks calculator to do things. So that will make it interactive. It's not graded yet, but eventually there'll be actual activities, and you'll put in answers, and you'll get the scores and kind of start working through the homework. But we'll do this again one more time, sort of this way. Let me do a presenter view. Put this down. And this will allow us to use the NumWorks calculator also as we go through things. Okay. So our focus will be on that last chapter 6. We were talking about the normal distribution. And we found ways that with certain sampling, even if the population was not normally distributed, we're able to use a normal distribution because of the way samples work. And usually research, we're dealing with samples to try to figure out what's going on with the population. And so actually what we're going to do today is look at ways to estimate what the mean of a population is. and we don't know it. We can't go out and just measure it, but we will. Is that not working? Is that? Oh, I see. I think it'll work now. Okay, good. So this next section, what we're primarily going to be working on is called a confidence interval. And what the idea is when we look at our data, it'll be normally distributed. We're looking for the mean. So we're building a confidence interval or a center section here. Okay. If it's out in the next chapter, we're going to be looking at trying to get things that are innovation, pushes things off into the tails. But right now, we're trying to look at what's normal, what's usual, what happens most of the time. So we're looking for the mean of our population by taking several samples. And you're going to see, hopefully, if you've, again, depending how you did on the test, and as you go back and review, some of the things we did, some of the calculations are going to be involved here. We're reusing them. But this time, there's actually a tool in NumWorks that will take care of it for us. Okay, so figure this out. So we're going to use a sample statistic, the mean. So X bar is the mean of a sample, to estimate the unknown population parameter, the mean of the population. So what's the average for the population, or for the population? Well, the only way we can do is take a lot of samples, and then we can estimate it. Okay. So this is what we're calling a confidence interval. How confident can we be? Now the size of that middle section is up to debate. Do we want to be 90% confident, or do we want to be 95% confident? So the wider the interval, the more confidence we can have. But you're going to see part of this is there is no, that's kind of what I like about statistics. It isn't always a complete science. Some of it is art. Okay. And so we get to make choices. So there's two types of estimates for the mean. One is a point estimate. A point is an exact value, a single value estimate for a population. And so what we'll use is we will use the mean of a sample that we pull. So we'll have some sample data, we'll get its mean, and we'll say that's our estimate. But remember, when we take a sample from a bigger population, if we took two different samples, would they have the same mean? What do you think? We're randomly choosing some data. No, it's not likely. It's likely the samples means would be different, okay? And so for that reason, the point estimate of just one mean is not, it's maybe a little helpful, but not real helpful. So what we do is we go with an interval estimate, which is a range of values. And what we're going to do is basically we take that point estimate, the mean of a sample, and then we calculate how much error we could have, and we make a plus or minus to that point estimate. Okay, so we get a sample, find its mean. We're going to have some calculations that get us sort of an error, which is a plus or a minus, and then that gives us our confidence interval that, hey, I'm going to be 90% confident that the population mean would be in here. And so that's what's nice with statistics, is we don't have to be 100% certain. In fact, it doesn't give us certainty, but it gives us close enough for most things. Okay, but that's all we're doing. And the nice thing is, NumWorks is going to do all the heavy lifting for us. It's even going to draw the pictures, and it's going to give us our answers. So we're going to see how that all works. So we can just focus on the concept. We're getting a sample. We're going to take we're going to get the mean of that sample, or NumWorks will get it for us. And then we're going to get this interval that says this is our estimate for that population mean. So we're going to use critical values. They call them Z critical. So we'll show, we were actually doing this in one of the exam questions specifically. So what these two values are, those are sort of the boundary points. So when we have a normal curve, if we get, say, 90% in here, we want a 90% confidence interval. This lower end will be Z critical minus Z critical, and this upper end will be positive Z critical. Okay, and let me just show you right now how we can obtain that with our NumWorks calculator. Because we've actually done this before. So I'm going to show you how we get those critical values. Although when we're working the homework problems, this is also embedded in the tool that we're going to use in NumWorks. But remember, from distributions, we go to the normal distribution. We're going to do the standard normal, because remember, whenever we have a z-score, that is a standard normal. So mean is 0, standard deviation is 1. We're going to leave those. And then let's say we want a 90% confidence interval. Well, remember, we're looking for the middle section, so we come to the middle. And then we put in, we want 90%. And these are our critical values. Notice they're the same value, one's negative, one's positive. So you'll see this number come up. If you have a 90% confidence interval, you'll see the number negative 1.645. They do it to usually 3 decimal places, or possibly negative 1.64 to positive 1.64. Okay. If we want a 95% confidence interval, what would we put in there? 95%. Excellent. Seems, yeah, 0.95. And we'll change that. And you'll see in a little bit later on, it'll all be there. Notice the Z values have changed. It's now negative 1.96. You'll see this one later in the slides for 95% confidence interval. So these values won't ever change because this is based on the standard normal. Some people will just write these down and memorize it. So if you're 95% confident interval, these are the values we will use. However, hold on, we're going to see that the tool we're going to use will actually incorporate most of this. But if you never need to know what these critical values are, we can use just the normal distribution. That's where they're coming from, right? And this is what we were working on. In fact, there was a question on the test that was very similar to something like this, okay? And again, in the next chapter, we're going to look at trying to be in the tails, which means that's the unusual part. The shaded area is the usual, what's sort of expected to happen to be in this region. These little unshaded regions in the tails, those are unusual values. Okay. How are we doing so far? Okay, kind of sense. That's all we're looking for. Okay. And so we get this picture. The blue shading is kind of what we're looking for. It's our confidence interval, and we're going to see that we'll have the confidence that, again, from our sample, that we're able to say that we're 90%, in this case, maybe 90% confident that our population mean is somewhere in this interval. Okay. This door opens. Of course, they've got a grate up there, so we still get stuff coming through. Anyway, okay. And so, yeah, so for a 90% confidence interval, we see values just like we looked up, negative 1.645 to positive 1.1645. We did a 95, we would have different values there, but our tool will always be able to look these up. And I believe in the homework, I believe, I looked up, there's going to be some times where they will ask for these critical values for different confidence intervals. 90 and 95 are kind of our standard, but we could do anything. We could do a 94. We could do a 93.5, right? We can do anything we need to, and we can always come here. If we want a 93.5, we just put in 0.935. And again, it's not a very standard one, but we've got some values we've got the critical values now. And what are those critical values? They're the endpoints of the shaded area. Okay. And remember, it's with the standard normal curve. All right. So that's the first two homework assignments. That's all you're going to need to do. I think the first one's 94%. You put that in and you'll have your critical values. Enter them in and you're done. Okay. And what does it mean? Again, when we get the confidence interval, we're going to see there's this calculation that'll go through. It's telling us that we're 95% confident that the population mean is in this interval. Okay, so that's what we're trying to, that's the Holy Grail is what is really that population mean. What's the average batting average for a professional baseball player? Something like that, okay? And again, if it's 95%, if our confidence interval is 95%, what percent is in the tails? Well, remember, we've got two tails, so 95%, 5% more gives us 100, so there's 5% that is split between the lower and the upper tail. Okay, so that's the other part that's always going to happen. Whatever our confidence interval is, the tails are 100 minus that, and then half, right? Because half in the bottom, half in the top. It's symmetric. Okay, so you'll kind of see how that all works as we go through things. And again, with 95%, we did this one, negative 1.96 to positive 1.96. And so we're adding and subtracting 1.96 from the mean. So we add it to the mean, subtract it from the mean, and we get this interval that just is what we're confident with. Again, we're going to see that there's a nice tool, and I think we'll see it in the next one, but I'm just going to introduce it here. The tool we'll start using is not just the distributions, but where is it? I keep moving these things around. They used to have them all together. It's inference. So sequences, it used to be, there was like this little block where you get all four tools are right there. So you just stuck with it. Now we got to look, we're going to be looking at inferences. And the cool part is in this one tool, intervals is going to be chapter 8, tests is going to be chapter 7. So the next two chapters will be just examining this tool. Intervals is the middle portion. Tests look for significance, so it looks for the tails. So it's really a very similar concept that we're working with. And once you learn how to use each tool, you're going to become experts pretty quickly at getting these answers. And not only that, again, it's going to give you not just a answer, but several different answers, okay, without having to do calculations, because it'll handle it all for us. But we'll talk about those calculations, okay? So sampling error, remember the difference between the point estimate and the actual population parameter. So again, the sampling error is the difference between what your sample mean is and the population mean. But remember, usually we don't know what that population mean is because the population's so big. The only way to find out is to get all the data, and we don't have all the data. So we do sampling. So in all these cases, our population mean, we don't know what it is. Sample mean, that's always going to be variable. It depends on that sample. It'll be different for each sample. So we're going to have this margin of error. And watch this calculation. It's sometimes we call it the maximum error, but what we're calculating is we'll get that point estimate from a sample, but we're going to do a plus or minus, and that error comes from the randomness. Again, remember, This was important last time. That's why I did the extra credit. As long as our sample is 30 or bigger, then we can do all of this. And that's the same thing we're going to be dealing with here, bigger than 30. Then the margin of error is going to be the critical z-value, which we just calculated using the distribution, times the standard deviation of the sampling, which is the standard deviation of the population, divided by the square root of the sample size. Do you remember this formula? Hopefully, because that was the last two questions on the exam. So when you get the exam, you'll review that. Those were the last two questions. That was really all you needed to do, is to take the standard deviation from the population divided by the sample size. And part of this is, I just want you to see it's part of it, but when we go to that inference tool, it's actually going to do all of this for us. Okay, but I want you to see what's happening under the hood, even though we aren't mechanics, we're drivers, but it'll help us out here. Okay, finding the margin of error. Let's go with this. Use a 95% confidence level to find the margin of error for the mean number of hours spent on required athletic activities by all student athletes in the in the conference, the population. So use the given sample and assume the population standard deviation is 2.4 hours. So again, we're looking at, what are we looking for? The average hours spent in athletic activities by student athletes for the conference, so it's nationwide maybe. They gave us a sample, and there's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8 times. So there's 40 in this sample. Our sample size is big enough, right? It's bigger than 30, so we can use the normal distribution. I have embedded a calculator here, so you don't have to enter all this data. I'm going to click on this. It brings up the NumWorks calculator, and it's actually already got the data entered in. So I'm going to walk through how to do the calculations here. So we're going to go full screen. And the first thing is to get down, we're going to go to inference. It seems like each calculator is in a different place. So just remember, we're using the inference tool. We're going to be using intervals in chapter 8. And then we have all these different things we can do with it. The proportion we're going to do in section 8.3. So that's a proportion rather than a mean. A proportion is a percent, but that's not what we're doing. What we're doing today is the mean, one mean. And what we're going to see is there's two different types of intervals. Today we're going to work with the Z interval, which is the normal. We can use that anytime we know the standard deviation of the population. So a lot of times we won't know the mean, but we will know how much variation is in a population. Sometimes we don't. When we don't, we'll use the T interval, and that's the first section we'll look at on Thursday. Okay, so just remember, so part of this is knowing which of these three different tests we're going to have that we can use. Z interval. So this first one, all Z intervals, okay? We're going to go okay. Then you can either input the statistics. So sometimes they will give you the mean and the standard deviation and everything you need. Other times they'll give you a data set like this one did. They gave us the data set. And I've already entered in all the values. Hopefully I got them all right. If I didn't, we might not match up, but I was matching up to my answer, so I figured I'd probably put it in right. But you have to put the 40 in here. And this one, you actually, once you finish putting in all your data, notice that was 40 pieces. And again, you could have done it, but if you click on that, it's already in there for you. Uh-oh, that's not supposed to be there. I think 25 was the last data. I think I must have, so yeah, let me get that out of there. It's not supposed to be there. So that's the first thing. With that 2.4 is then it gives you a place to put the population standard deviation. Now remember this question and all the questions in this section, they'll give you that assume the population standard deviation is 2.4 hours. Because if we know that, we use a z-test, and we'll talk about the different tests when we don't know. There's a way to do it if we don't know it. So that's we're going to put in 2.4. And then we put in the confidence interval. And again, this is up to the researcher to decide how much confidence they want to have. They want to have 95%. It's going to be a little bit wider. They asked us for a 95%, so we'll stick with a 95. Sometimes they'll ask for 90. Sometimes they'll ask for something else. But what we're going to see is we're going to hit OK. And then we're going to go to next. And we're going to get all the answers that we need. And the next few slides is going to talk about how the calculator calculated all these, but we're pretty much done. We can answer our homework questions from everything that's here. So now our sample mean, it calculated it for us. It's about 20, if we round this, maybe 19.925, but that came from the calculation. The sample standard deviation, so that got calculated for us. And again, that's different than the population standard deviation as we would expect. It's got our sample size, 40. It actually gets the critical value for us as well, because it's 95%. Notice that we looked that up, 1.95 or 1.96. So it's already got it for us. We didn't have to go back to the other app and figure that out. So it's got it, okay? It gets our standard error. Sometimes we're going to need, and our margin of error. So what we're going to see on the next page, it will also carry out the calculation, is the confidence interval is going to be this sample mean plus or minus this margin of error. Okay, margin of error is we add that and we subtract it, and that's our margin of error. Does that make sense? So if you're, but the nice thing is we don't even have to do that. We don't even have to add and subtract, because we go OK, or we go to next. We get the picture that we've got a 95% confidence interval. We're shown here, here's the mean, the 9.925 that it calculated, plus or minus 0.74375. So everything's right there. Sometimes in the homework, they will ask for the confidence interval as this plus or minus. So they'll ask you for the mean and then the margin of error. Sometimes they'll ask for the actual interval, which in this case, it did the addition and subtraction for us. So what we know is that the population mean, well, we're 95% confident that the population mean is somewhere between 19.18 and 20.66. Okay, and it's showing us here. The cool part is if we wanted to look up a 90%, we just go up here, and it's changing it's redoing the calculations on the spot. If we didn't have this, we'd have to go back and get some more scratch paper and probably do another paragraph of math work to get this. And notice if we want 85%, we just come up here. We wanted 98. So it gives us some other options along the way. And this is really helpful for a researcher. You could say, how confident do I really want to be, or do I need to be? And then that would tell you, we're going to see at the end, depending upon how confident we need to be, will tell us how big of a sample size we need, right? So it'll change our sample size as well. But again, standard will be 95% or 90, but there's other ones in there. So this has given us our answers, but notice we've also got enough information here to plug into formulas if we need to. And the next few slides, I'll show you those formulas. But again, we won't need to be using most of them, but we'll maybe see some connections to it. Okay. So, and again, the sample mean, we could have manually add them all together, divide by 40. I got 19.9. Remember, that's what we got. 19.925. Okay, so the calculator got that for us. And here's, again, if you go into this presentation, if you forget where to go, you know that you're doing inferences, You're going to go to intervals. You're going to go to one mean. You're going to do a z-interval. So all these things you have to kind of remember. And then we're going to do things where we use the other tests, setting the confidence interval here. Of course, we had to put the data in to get it all. This is all there. And then we get our confidence interval. Okay. And for most of the homework, the answer will be either this bottom confidence interval with the plus or minus, or it will be the two numbers that actually give you the endpoints of that interval. Okay. But it's kind of drawn it for us. Okay. For finding the margin of error, again, we'll walk through this, but again, the calculator handles most of it for us. The standard deviation of the population was given as 2.4 hours. Our sample size was 40, so that's good. And we can also use the formula to calculate it. So again, using the formula, you'd have to go look up and say, okay, the 95% confidence interval is 1.96. Notice we didn't have to memorize that because it's built in. Standard deviation is 2.4, and the sample size is 40. So this is what we were doing, right? At least this part was the last two questions on our exam. So that's what we were doing. That's what our calculator is doing, multiplying it by the critical value and coming up with our margin of error. And again, this is why I use the number, because it's all built into the calculator, and it also gives us that visual that we're getting this interval, this confidence interval. Okay, I haven't found any other calculator that does it quite like this. There's, again, some statistics programs, but they're usually more complicated to use. So this is a fairly accessible tool that helps us get those. And then again, once we have the mean, we're adding and subtracting this to get our confidence interval. So the error is about 0.7 hours. So whatever we get on our sample as our mean, we add and subtract that. It could be 0.7 more, or it could be 0.7 less. Okay, that's where our confidence interval comes in. And again, this is just showing we've calculated it here. And we get more accuracy. We can use as many decimal places as we want. When we're doing by hand calculations, a lot of times, once we start rounding, we can't use more decimal places, but the calculator gives us, if they want 2 decimal places, if they want 4 decimal places, it's all there. If they want 1, that's fine too. Okay. So, and then again, all you're going to do is you're going to take your mean, you're going to subtract the error, you're going to add the error, and that's your confidence interval. But again, remember the tool that we are going to use, the inference tool, it has it all built in, and it will do it all for us. Okay. Use the data example 1 to construct a 95% confidence interval. We've already did that, right? With here, we just clicked on because it's already inputted. And if we go all the way to the last, there's a confidence interval. They're showing us the graphic of it, that somewhere between 19.18 and 20.67 is our population mean. Okay. And again, these would be usual values. Oops. Okay. But that's how, if you had to do it by hand, you would add and subtract. Again, our calculator that we're using, the tool, will do it for us. But again, you have to know, you have to practice, you have to know how to use it. There's a couple questions on the exams, and it was just a matter of using the calculator in a particular way, and some people said, I forgot how to use it. So, and again, remember, you've got your note sheet, make some notes. The calculator will do the heavy lifting, but you've got to know which part of the tools to use. So that's, we are the managers of our data. We are the managers of this tool. And we have to direct it in the right direction, and then it will reward us by giving us valuable information. Okay. Again, did it for us. You could draw it on a number line, but again, our calculator does that for us. That's the little picture it's giving us, the interval. with the mean in the middle, 19.9. Okay. So let's just do one. That is actually going to be a lot easier to do because they don't give us data. They give us everything we need. So college admissions director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, the mean age is found to be 22.9. From past studies, the standard deviation is known to be 1.5 years for the population, and the population is normally distributed. Now, got a question for you. The sample is only 20, and our tool is based on the normal distribution, and we said it has to be 30 or more, but there was one caveat. Why can we use the normal distribution on this one? Excellent. So it's got that secondary, even though it's less than 30. If it was 30 or more, we wouldn't even have to worry, right? But it's less than 30, so we have the population is normally distributed. So remember, that's why I put those 2 extra credit ones in there. I wanted you to remember that. So yes, we can use it here, even though there's only a sample of 20, because the population standard. And again, what we're going to see is when we go to the tool, we just have to put this number in, and then the level of confidence that they want us to use. So I'm going to come back to this one, and I'm going to go back and start sort of from the beginning. Oh, inference. Let's back it up. Z-interval. We're going to input statistics this time, not a data set. And notice it asks us for the sample mean. So the sample mean is 22.9. And again, this is what your homework questions are going to look like, exactly like this. Population standard deviation, they gave us that as 1.5. Sample size was 20, because that's part of the calculation, right? The square root of that. Again, we don't have to worry about that. It's just there. And then what is the confidence level they wanted? Well, they want a 90%, so we put 0.90. Whatever they ask for, we give it to them. We go to next. Again, it's going to get the critical value for us. And the homework might not even ask for any of these. We don't need to give it. But it came up real quickly with the standard error. Again, that was a calculation. So about 0.55. So about half a year, plus or minus, right? So we come to the next, and we get our full answer. So on average, the men are 22.9 years old, almost 23 years, plus or minus 0.5, plus or minus half a year. So about 23 years, 23 and a half, 22 and a half is the average age for our population. Have a good one. Couldn't be easier, right? But again, you have to remember where it goes where and which tool you're using. But this has done a lot of complicated calculations in the background. And again, what I really like about this, if they wanted a 95%, I just go down a line. I got all my answers. I don't have to go back and recalculate, because I'd probably make a mistake if I did, right? Notice the mean didn't change, because that's going to be, but the error changed, so it's a plus or minus a difference. It's a wider confidence interval, right? 95%, you're going to see it's wider. If less confident, you have a more narrow, because you're giving less room for it to be in there, okay? And that's the nice thing, is you can play with this a little bit. And again, I've not seen any tool or calculator that would do this. Usually you have to go back to the beginning and tell it you want a different confidence interval. So that's there. And there's that in there. And again, to construct the interval, once we go through all the calculations, again, this was what the calculator did for us. It came up with 0.6. You add and subtract it, so 22.3 to 23.5. This is for a 90% confidence interval, and you end up with that. We had the 90%, right? 22.3 to 22.5 if you round that up. Exactly what they got here. Okay, so we're going to get the answers. Just remember all that it's going through to get you there. But with this calculator, it handles everything. You just have to remember where everything is. Okay. The thing is we're not getting a probability. We are actually getting a level of confidence because of the way the science works. And what this is, the way we're thinking about it, if we took a large enough sample or we took many, many samples, that we would be able to see that in this case, 90% of them, their means would be within that interval. Okay. If it was a 95%, we would be 95% of those would be there. So what's happening is, again, we're trying to estimate this population mean. We pull up different samples, we get different means, and we get different intervals, but we see that the actual population mean is contained. In this case, would be, if this was 10 of them, 9 of them, so that, I think that's what they got. You can count these. 9 of them overlap with the population mean. 1 of them doesn't, but that's the 10% that's outside of our confidence interval. Yeah, we're only 90% confident. If we had a 95% confidence interval, then 95% of the samples we pulled up would have the mean in their level. Okay, so that's all the things we're doing. And again, think about that activity or something that you're, what kind of data would you be collecting, measurement, to get a mean on, and maybe applying it, that you could sample it, you could apply it to a population. The average golfer gets this kind of a score or something. This one I'm going to go over lightly because this is not in the homework yet. It'll be in the homework after the last section that we do. So we'll look at this in more detail on Thursday. But I just want to go over the calculation. And what basically we do is we got to work on this, is we take this error formula, which the calculator will do for us, and we solve it for n. So I'm going to do that so you won't have to do it each time. And so when we get to the end, we'll use this formula to calculate what sample size we need. And this is an important thing when you're actually going to go out and collect data. I mean, you could set up your whole proposal to do research, but before you actually start collecting data, you want to know what your sample size needs to be before you do it. Because you don't want to get back and say, I took a sample of 30, and then your calculations, maybe your margin of error is too big. Your mentor says, nope, that's not good enough. Go get some more data. Well, I can't. I was out on the island and I'm not on the island anymore, or whatever. Sometimes you're out collecting data. So you want to make sure you collect enough data that your results will be sufficient. Okay. You don't want to have to go back and take some more. If you need 45, you get at least 45, right? But you also don't want, it's expensive to get data. You don't want to collect 300 when 100 would do, okay? Or 45 would do, okay? So this is a calculation we will be doing a little bit later. I don't want to focus too much on it because it's not in the homework in this early section. We'll look at it again towards the end, but I just wanted to bring it up. It's just a algebra of this formula that's being used anyway. And what you could do is you could take your NumWorks calculator and do some guess and checking. But if I had this sample, you could keep changing the sample size and you would see its effect on the margin of error until you got it to what you wanted it to be. So that's all you're doing. Okay. So this one just said if our boss says you need your margin of error can only be half a year, 0.5, you put in that error and sort of do the backwards calculation, you find you need 88.5, so you go get a sample of 89. And it will always be this sample size will give us a margin of error of 0.5 with the details we already had. We want a lower error, say 0.4. We would put that in there. We'd see we would need to get more. we'd need a larger sample. If our error could be larger, then we could get a smaller sample. Okay, so you could play with that, and again, we'll do that later. But that's a very important part of when you're doing research, and to know that the sample you're getting is going to be sufficient for you to make any kind of claims. And that's one of the things they'll coach you on. Again, sometimes you're doing qualitative research, so there's a whole nother way of doing research too that we don't worry about all this. But if you're doing the numerical part, collecting some measurements and stuff, you want to make sure you have enough measurements. Okay, so we'll talk about that. But this is the last page. Remember, those are not in the homework. The main thing I want you to do is there's 5 questions. First 2 are about confidence intervals using just finding those critical values. So you would use the normal distribution, the standard normal, right? And just find those middle 94% or whatever. And then the other 3 questions are like the one we just did, finding a confidence interval. And I believe they are all where you just enter the data, you enter the statistics that they give you. You don't have to enter the data, I'm pretty sure. If I'm wrong, sorry about that, but you enter a few points, okay? But like this, they'll give you the mean, the standard deviation, and notice this is the population standard deviation. So they'll say this, in Thursday's lectures, we'll look at when we don't have the population standard deviation, and then we do a slightly different test. We'll talk about that. But you put these in, and then you're able to get the margin of error, the critical values, anything they might be asking. But you go to the next page, and they've actually done all the calculations for you. And again, just watch for what the question is asking, whether it wants the mean plus or minus the error, or if it just wants the error, or if it wants the full the interval itself. Okay, is that good? And again, in the future, I'm looking at a way to kind of incorporate this into like a little quiz so that you would follow along. But I'm not sure. We'll see what we get there. But I feel more confident that you'll have greater success as you go through these, because there's only 5 questions here. So I'm going to see if we can, and you know everything we went over deals exactly with that homework assignment. So if you'd have that done by Thursday, you're going to see that what we do on Thursday is very similar, but we're using 2 other concepts, so there's slight changes to it. But get a little bit of practice with that. Do those 3 problems, 5 problems, right? But the 3 with the confidence intervals, and you're going to see Thursday will be very easy to follow along with, because we're going to be using the same tool in a slightly different way, but it'll all make sense. Okay, so that's what I have for today. You've got the rest of the time if you'd like to start to work on the homework. You'd probably get it done before, I think you could probably do it in like 10 minutes.